Motion problem revisited. The initial value problems for the velocity and position. Suppose an object moves along a line with unknown velocity vt for the t greater than or equal to 0. Its position st is found by solving the initial value problem or the differential equation s prime at t equals vt, where s at 0 equals s0, which is an initial position. If the acceleration of the object at is given, then the velocity vt is found by solving the initial value problem or the differential equation, the vt at t equals a at t, with the initial velocity v at 0 equals v0. The first problem, a mass oscillates up and down on the end of a spring. Find its position st relative to the equilibrium position if its acceleration is at equals sine of pi t, and its initial velocity and positions are v at 0 equals 3 and s at 0 equals 0 respectively. Sa of t equals sine of pi t, and also the relationship that the v at t is s prime at t. A at t is the v prime at t, which is the same as s double prime at t. So we can rewrite this as the initial value problem for the differential equations s double prime at t equals sine of pi t with initial velocity v at 0 equals 3 and the s at 0 equals 0, where v at 0 is the same as s prime at 0. First, we find the s prime. S prime at t is the antiderivative of s double prime, which is the antiderivative of the a function, or the antiderivative of sine of pi t with respect to t, and give us the function negative cosine of pi t divided by pi. So write it as negative 1 over pi multiplied by cosine of pi t plus c1 as a constant of integration. We are going to use the condition to find the value c1. So since this is the v at t, so right now the v at t is of the form negative 1 over pi multiplied by the cosine of pi t plus c1. We're going to find c1 using v at 0 equals 3, and v at 0 is h prime at 0. As t equals 0, v equals 3. 3 equals negative 1 over pi multiplied by cosine of 0 plus c1. Cosine at 0 equals 1. Therefore, the c1 is 3 plus 1 over pi. Now we get the velocity function, which is s prime or the v at t, equals negative 1 over pi multiplied by cosine pi t plus 3 plus 1 over pi. And next, we are going to find one more antiderivative to get to the position function s. So next, we're going to find s at t. So s at t is the antiderivative of the v at t with respect to t, or the antiderivative of negative 1 over pi multiplied by cosine of pi t plus 3 plus 1 over pi with respect to t. So s at t equals negative 1 over pi multiplied by sine of pi t divided by pi plus 3 times t plus 1 over pi times t plus another constant of integration. Or we can write it as negative 1 over pi squared multiplied by sine of pi t plus 3t plus 1 over pi times t. And next we are going to find the value c2. So we're going to find c2 using another condition, which is s at 0 equals 0. For s equals 0, t equals 0. We have 0 equals negative 1 over pi squared times sine at 0, which is 0, plus 3 times 0, which is 0. 1 over pi times 0 going to be 0. So then we get C2 equals 0 for this second antiderivative. Now, we summarize it as the position function s at 0 or s at t, sorry, is in the form of negative 1 over pi squared multiplied by sine of pi t plus 3 times t plus 1 over pi times t.